A larger attic fan can make the airflow path worse when the intake path is weak. That is why attic fan sizing is not measure the roof and by the biggest CFM. A useful selection starts by asking what problem exists, where replacement air can enter, what the fan is rated to deliver, and whether the attic can be depressurized safely. This video builds that decision from evidence. It does not promise a temperature drop, energy saving, moisture solution, code result, or fit for a particular home. Before sizing a powered fan, decide whether powered exhaust is the right intervention. High attic temperature can coexist with ceiling air leakage, poor insulation, blocked passive vents, duct leakage, or ordinary solar heat gain. Moisture may come from a roof leak, bathroom or dryer exhaust, or humid indoor air leaking through the ceiling plane. A fan does not repair those causes. Record the symptom, season, weather, roof condition, insulation, and existing vents first. If the problem is water entry, air leakage, insulation, or exhaust routing, correct that pathway before treating fan capacity as the answer. Next, draw the intended pressure path. Outdoor air should enter through defined low-level attic intakes, cross the attic, and leave through the powered roof or gable exhaust. The occupied house should remain outside that intended path. If soffit vents are blocked, undersized, or unevenly distributed, the attic can go negative and pull conditioned air through ceiling penetrations. The U.S. Department of Energy also warns that depressurization can affect naturally drafted combustion appliances. The drawing must therefore include intake vents, the attic volume, the exhaust location, the ceiling leakage boundary, and combustion equipment, not just a fan symbol. Now collect the sizing inputs that a product label cannot supply. Measure attic floor area and, where roof shape makes the volume unusual, estimate the actual ventilated volume. Identify intake types and their published net free area, not their outside dimensions. Record existing high-level passive exhaust openings, baffles, screens, insulation blockages, roof pitch, roof color, climate, controls, and the intended operating window. Confirm whether the candidate rating is a complete unit certified airflow value and note its test condition. These inputs create a sizing brief, a product photo or blade diameter does not. For a transparent first screen, the Home Ventilating Institute publishes guidance for HVI certified powered attic ventilators. It describes at least 10 attic air changes per hour and a common shortcut of attic floor area multiplied by 0.7 to estimate minimum CFM, with an additional factor for dark or steep roofs. Treat that as an HVI screening reference, not a universal law. Local code, manufacturer instructions, unusual attic volume, climate strategy, and the decision to use powered ventilation can change the answer. Never round a screening result upward before checking whether the intake and pressure boundaries can support it. The intake check is the part most often skipped. HVI publishes a makeup air screening guideline of 1 square foot of inlet net free area for each 300 CFM of powered attic fan capacity. Net free area means the open area after louvers, screens, and other restrictions, not the rough opening. Use current vent documentation, add the verified inlet areas, and check their distribution along the eaves. If the required intake is not present, the correct response may be to improve the inlet path, reduce the proposed exhaust, reconsider powered ventilation, or redesign the system. A larger fan is not a substitute for makeup air. Rated airflow is still not the same as installed airflow. Screens, shutters, guards, curb transitions, ducts, bends, wind and dirty openings add resistance and move the fan's operating point. Compare complete unit certified ratings at the stated test condition, then check the manufacturer's allowable installation and controls. Do not compare two products by motor watts, blade diameter, or a free air headline alone. The useful question is whether the selected unit and the verified inlet and exhaust path can deliver the design intent without creating an unacceptable pressure difference across the ceiling plane. Location and control logic belong in the same design review. An exhaust point should not short-circuit nearby intake air or leave remote attic zones stagnant. Thermostats, humidistats, and solar operation do not remove the need to define the objective and safe operating conditions. A control that runs the fan longer can also extend unwanted depressurization. Climate, roof assembly, and moisture strategy matter, so this video does not prescribe one temperature or humidity set point. Controls should follow the selected product instructions and a site-specific plan, with a clear way to isolate the fan for inspection and service. Roof and electrical work create a separate stop line. Cutting the roof, locating the opening between structural members, building a curb, flashing against wind-driven rain, preserving drainage, providing guards and clearances, wiring a disconnect, grounding, fire separation and permitting are not animation-level decisions. Combustion safety also cannot be cleared by a checklist alone. A qualified local contractor or engineer must reconcile the roof assembly, structure, electrical system, appliance venting, manufacturer instructions and local rules. This is a conceptual planning guide, not a roof cutting or wiring tutorial. These 3 company-owned reference images provide limited hardware context. 1 shows roof fan category forms, and 2 show a solar roof exhaust hood and panel geometry. They contain no customer data, but they also do not prove an attic installation, flashing method, intake path, model rating, solar runtime, cooling, savings, safety or code approval. The third-party video found in the archive search remains excluded because its branding, marketing statements and industrial flat roof scene do not establish this residential evidence chain. The airflow and installation explanation therefore uses dedicated vector diagrams instead of pretending a catalog image is field evidence. A safe conceptual installation sequence begins with the approved sizing brief and a site survey. Verify the attic boundary, intake NFA and distribution, select a compatible listed product and location, resolve structure, curb and weatherproofing details, resolve electrical, controls, fire and combustion questions, install only to current manufacturer and local requirements, then inspect the complete air path before energizing. This sequence intentionally stops short of dimensions, fasteners, wire sizes, and flashing steps. Those details belong to the actual roof, product and jurisdiction, not to a generic YouTube frame. Commissioning decides whether the sketch became reality. Confirm rotation and exhaust direction, unobstructed intake flow, control response, weather protection, vibration and access for service. Measure the pressure relationship between the house and attic with the fan off and on, and have combustion safety evaluated where relevant. Look for air being pulled through ceiling penetrations rather than the intended soffit path. Record the installed unit, settings and observations, then correct the pathway before declaring success. Use a 4-part handoff, problem and climate, attic geometry and air path, verified intake net free area, and the product's certified rating plus site safety review. If any block is missing, pause the purchase and measure it. Longwall can help translate a documented airflow requirement into a fan specification, but the building and installation decision remains site-specific. Save the handoff card, take it to the contractor or engineer reviewing the attic, and choose evidence over a confident guess.